You ever stop and think about just how much science is happening in your kitchen every single day? Well, today we're going to become kitchen scientists and investigate an everyday mystery. It's something that feels like a magic trick, but it's actually pure chemistry. And it all starts with a little disappearing act that I bet we've all seen. So picture this. You're making a cup of tea, maybe some lemonade, or you're mixing up some ingredients for a cake. You pour in the sugar, give it a quick stir, and poof, it's gone. It just vanishes. We've all done it, right? And that's our big investigation for today. Where does that sugar actually go? I mean, it can't just disappear into thin air. And what's the deal with that moment when you add maybe one spoonful too many and it just sits there at the bottom, totally refusing to vanish? Come on, let's crack this case. Okay, to solve this mystery, we've got to learn the lingo. We need to understand the science that's happening right there in our glass. Like any good investigation, it all starts with identifying the key players involved in this whole act of dissolving. All right, first up, we've got the solute. That's just the fancy science name for the thing that gets dissolved. So in our case, it's the sugar. You can think of it as the star of our disappearing act. And of course, every star needs a stage, right? Well, that's our solvent, the substance that does the dissolving. For a cup of tea, the water is the solvent. It's where all the action happens. Now, you put the two of them together, and what you get is a solution. And this isn't just any old mixture, it's what scientists call a homogeneous mixture. That just means everything is perfectly, evenly spread out. But what does that actually look like? This image here shows it perfectly. See, if you just mix sand and water, you get this clumpy mixture where you can still see all the little individual grains. But when sugar dissolves, it creates that homogeneous mixture, a true solution. It means it's the same all the way through. You can't see the tiny sugar particles anymore, no matter how hard you look. So here it is, the big secret behind the magic trick. The sugar doesn't actually vanish. Not at all. Its tiny little particles just break apart and spread out so evenly between the water particles that they basically become invisible. But hey, don't just take my word for it. There's actually a really simple way to prove it. And here's the proof. It's all about weight. If you weigh the water, then you weigh the sugar, and then you weigh the final solution after everything's dissolved, guess what? The numbers add up perfectly. The total weight is exactly the same. Nothing was lost. The sugar is all still in there, it's just hiding. Okay, so we get what dissolving is now, but what controls it? Why does it sometimes happen faster, or why can you dissolve more of something sometimes? To really get to the bottom of our mystery, we need to identify the variables. These are the conditions we can change that might affect the whole outcome. So, our prime suspects are these three things: the temperature of the water, how much water you use, and whether or not you stir or shake it. Each one of these seems like it could definitely speed things up, or slow them down, or change how much sugar dissolves. But to be good scientists, we have to test them the right way. Right, a good kitchen scientist doesn't just go around guessing. Nope. We need a reliable method. We need to test our suspects one by one to see what effect they really have. And that calls for a proper experiment. So, the key to any good experiment is something called a fair test, and it's all about isolating your suspect. The rules are super simple. First, you only change one thing at a time. That's it, just one. Second, you keep everything else exactly the same. And third, you just watch closely and see what happens. That is how you know for sure that any change you see was caused only by that one thing you tweaked. So, let's put temperature to the test. Imagine we have the same amount of water, the same amount of sugar. The only variable, the only thing that's different is one glass is cold and the other is hot. And what happens? Well, the result is crystal clear. Way more sugar dissolves in the hot water. And that's because the hot water molecules are zipping around faster, making more space for the sugar particles to slip in between them. So yeah, temperature is definitely a huge factor. This brings us to the climax of our investigation. We know hot water helps dissolve more sugar, but does that mean we can just keep adding sugar forever and ever? Let's find out. I mean, this is the big question, isn't it? If we just keep spooning sugar into our hot tea, is it just going to keep dissolving forever, or is there some kind of breaking point? And here it is. Here's our answer, the saturation point. This is the official scientific term for when the solvent, our water, is holding the absolute maximum amount of solute, our sugar, that it possibly can. Think of it like a sponge that's totally soaked with water. At some point, it just can't absorb a single drop more. It's full. And that is the final piece of our puzzle. Once you hit that saturation point, the magic trick is over. The water is literally full. Any extra sugar you add has absolutely nowhere to go, so it just sinks to the bottom. That is the real reason your sugar sometimes stops disappearing. Mystery solved. Okay, so we've cracked the code of dissolving, we've learned the terms, we've identified the saturation point. Now let's take all this cool knowledge out of the science lab and bring it right back where we started, our kitchens. And believe me, this isn't just some abstract science theory. Think about baking. When a recipe calls for a really specific amount of sugar or flour, there's a reason for it. It's controlling the chemistry. Understanding these saturation limits is the secret to getting that cake batter or that frosting just right. This quote just sums it all up so beautifully. All these processes we've been investigating, dissolving, variables, saturation, they are happening every single time you cook. Your kitchen really is a laboratory for some pretty delicious experiments. So there you have it. You've solved the case of the disappearing sugar. You've got the tools, you've got the vocabulary of a true kitchen scientist. So I guess the only question left is, what everyday mystery are you going to investigate next?